Hey everyone, in this video we are going to complete the identity on the screen. Tangent x times the quantity of cotangent x minus cosine x. I like to switch x and theta. I just pulled this from a different document, so here we go. So when you're completing an identity or simplifying a trig expression or rewriting a trig expression as a single trigonometric function or whatever directions might say, right? Even if you're not entirely sure what they say, like go with your instincts, you're probably simplifying in a case like this one, right? Usually it won't even give you that equals portion right there. It'll just sort of, stop like that. But in this case, it does have equals question mark and it would say part of a multiple choice question or something to that effect. So a go-to method for me is to, one, get rid of my denominators as long as things are only connected with multiplying and dividing. I usually do that by pulling into play the reciprocal identities. I don't need that here right now because I don't have any denominator overall, right? Then after that, what I like to do is go into panic mode, which is changing everything into just two ingredients, sines and cosines. So that's where I'm going to start with this one right now. Now, some of you, I feel like it's very common that people cannot help themselves when it comes to the distributive property. Like people just love to distribute, and that's fine. So it might be better this time. I'll do it both ways. You can't always know right off the bat unless you stop and think about what will lead to what. You can't always know what will be the most practical or fastest way to do something. As you get better and more experience, you're going to be able to sort of start seeing, no, this is going to be much cleaner, easier, less to write down. That other way is going to be a mess, but it takes experience. So I'm going to start with panic mode. That's a method a lot of people fall back on. So tangent, I'm going to rewrite it as sine theta over, and I'm only writing all the way to the left because I'll probably do the other way on the right. So there's my tangent using the quotient identity. Cotangent, well, it's the reciprocal, so it really is this, but flipped over, right? So over sine theta, and then minus cosine, make sure you always read carefully and that we don't think it's cosecant, which is really, I guess, over 1. Now, if the inside was something where it might make a lot of sense for me to find a common denominator, I might go for it. But this is me thinking ahead. If I wanted to find a common denominator on the inside, I'm going to multiply this one on top and bottom by sine. This numerator is going to be then cosine sine, not even cosine squared. If that were a 1 and it was going to be something like 1 minus cosine squared, which is part of the rearranged Pythagorean identity, I might go for it. But in a case like this one, it's not that desirable to do, okay? So from here, I might be like, all right, well, I guess I could distribute now. So could I have distributed first? Probably, and it would really just bring us to the same thing. But it was nice to see if the inside could have been dealt with differently. So let's keep it moving. I'm going to write everything out. The better you are, the more you're going to be able to do in your head. But remember, when you're verifying identities or simplifying, when it comes to trig in general, it's all about the work. It's all about the work. So you don't want to skip steps because it's not about the final answer. It's about the process. Your teacher needs to see, how did you get there? Because could you get there by dumb luck? Yeah. But could you get there by using valid techniques and rules and applying them correctly? Right, yes, that's the goal. So you want to show all your steps, okay? From here, I distributed there. I just have them written. I'll simplify in a moment. And now this will also distribute there. Common thing I see when looking at student work is a lot of students in their head will make the mental commitment to be like, I'm going to distribute. But then when they get to this step, they don't write this. And by accident, they just kind of keep going, right? And they're going to forget to distribute. So be careful because it happens all the time. Here, multiply is really just jumbo simplify. Anything on top and bottom can reduce. They could be right above each other. They could be neighbor fractions, as long as it's all connected like this with multiplication and division only. I cannot cancel, or reduce rather, this sine theta with that one. They are separated by a minus sign. Not allowed. Don't do it. This cosine and this cosine, not allowed. don't do it. So this sign, let me even color coordinate so we see what went with what. Those we're able to cross out with one another. All right, then these cross out with one another. That does not equal 0. I hope we all know that anything divided by itself is not 0. It doesn't cancel, it reduces, and it becomes 1. Good. So 1 minus, all that's left here is sine theta. Now this is going to be an example where that's it. You can't go further. We can't get it down to a single trigonometric function. It's just going to be the difference of 1 minus sine theta. That's really as far as we can go. If it were 1 minus sine squared theta, then yes, you can use Pythagorean identity and it would become cosine squared. But that's not what we have, okay? It's not what we have, so we cannot do it that way. Now let's just take a quick peek at just how it looks if we started with distribution right away. So I have then tangent theta times cotangent theta, then minus tangent theta times cosine theta. Now you might notice that here I wrote the little dot for multiplying, here I wrote nothing. It doesn't matter. The number of times I get asked about that is crazy. Being right next to each other in a case like this implies multiplication. You could put a dot, you could put parentheses. Just don't use x because x has a job. It's a variable now, you know, and that's another reason I like to use theta. I like to avoid x because I don't know who's using it as the variable. So it doesn't matter right there. Now, maybe in your head you think, well, tangent is tangent, cotangent is 1 over tangent. That's fine. That still gives you 1 for that first term right there. And then minus. Now, if this was cosecant, then I might rewrite tangent using secant over cosecant instead of sine over cosine because of what's next to it. So these are decisions you make as you go based on other details. But I'm going to rewrite tangent with the original quotient identity, which is sine over cosine. And then cosine can stay as it is, which is really cosine over 1. And again, reduce, minus sine theta, and you get the same answer. So while sometimes things might require more work, you might like them better because you could see it better, you feel more confident about it. When you don't maybe have as much to work with, maybe you don't feel as good about it. So it's your call, choose your own adventure, and figure out what's best for you. So I hope that you are feeling quite confident. If you enjoyed the example and understand it, thumbs up. If you don't understand it, you need more explanation, give a thumbs down. If you did it a different way, please let me know in the comment section down below. And otherwise, just click through for the next example. And I hope you're feeling smarter at this moment, at this time. Adios.